Here's our video for Unit 7, Day 3. So yesterday we were talking about triangle congruence theorems, or shortcuts. Today we're going to talk about similarity theorems, or shortcuts, so ways we can tell if two triangles are similar. So what we talked about 2 days ago, to tell if two triangles are similar, the corresponding angles on those triangles will be congruent, and the corresponding sides will be proportional. So they'll be the same shape, but they'll be a different size. One will be bigger than the other triangle. Right? They'll have a common ratio in between the two triangles. So for similarity, we only have 3 shortcuts for similarity. We have 5 for congruence, but only 3 for similarity. The first one is called angle-angle similarity. So again, instead of checking all 6 sides, we're just checking all 6 pieces of the triangle. We're just checking either 2 or 3 pieces on each one of these. So this theorem or shortcut tells us if two angles on one triangle are congruent to two angles on another triangle, then we know those two triangles are going to be similar. Right, so all we have to check is they have 2 congruent angles, and then we know that all 3 angles will be congruent, and all 3 sides will be proportional. Remember we talked about on 2 days ago is that if we know 2 angles in a triangle, we can always find that third, because all the interior angles in a triangle add up to 180 degrees. So if we know just these 2 angles, angle, angle, we actually know that all 3 angles are congruent, and that gives us our shortcut. So here what it tells us is that angle B is congruent to angle Y, angle C is congruent to angle Z, and that gives us enough to write a similarity statement. We know that the triangle ABC will be similar. Remember, similar is like the congruence statement without the equal sign. Just has the squiggle. So triangle ABC will be congruent to triangle XYZ, and the reason is angle-angle similarity. And again, just like with the congruence theorems, we know some information once we use this shortcut. Right now we know that the third angles will be congruent, angle A congruent to angle X, and we know that all the sides will be proportional, so the ratio of AB to its corresponding side, XY, will be the same as the ratio of all the other sides, so BC to YZ, and also ZX, sorry, AC to XZ. Right, these will all have the same ratio. So this is how we write using symbols that the sides are proportional. So our second theorem or shortcut for similarity is side angle side similarity. So we have side angle side for both congruent and similarity, but they mean different things. Remember that with similarity, the sides are going to be proportional. So we have 2 sides on one triangle proportional to 2 sides on another triangle, and then the included angles, remember that means the angles in between those 2 sides are congruent. then we know those two triangles are going to be similar. So again, that means the same thing. Similarity means all three angles are congruent. And all three sides are proportional. So here right away we see the angles more congruent. We have angle A congruent to angle D. And then we see that there's a common ratio between the sides on either side of that angle. Right, 6 to its corresponding side 3, and 8 to 4 have the same ratio. These are both a 2 to 1 ratio. Remember that this is called the similarity ratio. So we see that those two sides are proportional. The angles in between are congruent. We can go ahead and write our similarity statement. Triangle ABC is similar to triangle DEF. And the reason we know that is side angle side similarity. And again, once we know that, we know some other information now about the whole triangle. Since they're similar, we know that angle B will be congruent to angle E, that angle C will be congruent to angle F. We also know that the ratio of BC to EF will be 2 to 1. So I have one more shortcut for similarity. Again, this is one that's also a congruent shortcut, but it means something different with similarity than it does with congruence. This one is side-side-side similarity. So this theorem says if three sides of one triangle are proportional, not congruent, but proportional to three sides on another triangle, then we know those two triangles are similar. Right, which again means we know that all three angles are congruent and that all three sides are proportional, which obviously we checked on this one. So here again we have no angles marked here, but we have three sides. We check to see that there's a common ratio between the sides on one triangle to the other triangle. So if I look at side GI, see it has a length of 7, that corresponds on the other triangle to side JL, has a length of 14. Side GH has a length of 8, corresponds to side JK that has a length of 16. Same thing on the bottom here, side HI has a length of 9 and corresponds to side KL, which has a length of 18. So see there's a common ratio between all the sides, 1 to 2. All these side lengths on the left triangle are 1/2 the length of their corresponding side on the right triangle. So just by checking that, we can already write our similarity statement. Say that triangle GHI is similar to triangle JKL by side-side-side similarity. And once we use the shortcut, we now know that all the remaining pieces of the triangle, which is the three angles, are going to be congruent here. So angle G will be congruent to angle J, angle I will be congruent to angle L, and angle H will be congruent to angle K. Right, even though that information wasn't given to us, we could figure it out because we found out that the two triangles were similar, and we did that using this shortcut, side-side-side similarity. So last piece of the notes, just to avoid confusion, we're going to talk about the difference between congruence and similarity. So there's some that are close to each other. They both have side angle side and side side side, but they mean different things. So with congruence, everything is congruent. The angles are congruent, and the sides are congruent. With similarity, our angles are still congruent, but now our sides are proportional instead of congruent. We have a different notation also. If you see the equal sign with squiggle, you know that means congruence. And if you see just the squiggle, that means similarity. Alright, and then for congruence we have 5 shortcuts, 5 theorems. We have side, 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 which is 3 congruent sides. It's different than similarity, side, 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 which is 3 proportional sides. For congruence, you also have side, angle, side, which means 2 sides congruent and the included angle. Side, angle, side for similarity, we have 2 sides proportional instead of congruent. And then the included angle is still going to be congruent. And for congruence, we have angle, side, angle, and angle, angle, side. Again, everything is congruent. And with similarity, all we have to check is just those 2 angles. Just having the 2 angles congruent automatically makes the 2 triangles similar. So that's it for the notes for today. If you want to look for any other resources, practice problems, or a better video, you can look and search for triangle similarity theorems.